Welcome to MathLink Academy, where we connect the dots. I am Mr. C, and in this unit, we're going to cover the law of sine. So let's get started. So the first thing we want to do before we cover the law of sine is talk about oblique triangles. An oblique triangle is a triangle that does not have a right angle. And so when we talk about the law of sine, we're talking about solving triangles, their sides or their angles, that are oblique triangle, which does not have a right triangle. If it was a right triangle, we could use sine, cosine, tangent, usually to solve for the unknown. But since we're talking about non-right triangles, we're talking about oblique, we're going to have to use the law of sine at times. An oblique triangle may be either acute or obtuse. In an acute triangle, each of the three angles is acute or less than 90 degrees. In an obtuse triangle, one of the angles is obtuse or greater than 90 degrees. Now, this is important to understand how to use the law of sine and how to set it up. In any triangle, the sides are proportional to the sine of their opposite angles, or stated as a formula. This formula you want to memorize so you know how to use the law of sine. It's pretty straightforward. But before I write the formula, or before we do the formula, I want to write the triangle, how you should write and how you should label your triangle. In this case, this is our triangle. And our angles are going to be capital letters. Capital letter A, capital letter C, and capital letter B. Now, what we need to do when we do the triangles, oblique triangles, or pretty much any triangle, we want to have the sides, lowercase letter, that are opposite to the angle. So what I mean by that is, if you have angle B, which is a capital letter, the side B will be opposite, and it'll be a lowercase b. Angle A is right here, and so the side A will be opposite to A, which is a lowercase a, and the same thing for angle C and side C. If we do this, we're going to correctly find the answer. So remember, first label the angles A, B, C, and then label the sides opposite to the angle so you know how to use the law of cosine. And so once we label our triangle correctly, the law of cosine, the law of sine, because we do have a law of cosine, but the law of sine would be little a over the sine of A is equal to B over the sine of B, which is equal to C over the sine of C. Again, they're proportional and they're equal in their proportion. The law of sine is used to solve the following two kinds of oblique triangle problems. Problems where any two angles and any side of an oblique triangle is unknown, or a problem where any two sides and an angle opposite one of the given sides of an oblique triangle are known. So let's look at an example at this time. Given two angles and a side, determine side X of the oblique triangle in the figure below and round the answer to 3 decimal places. So let's notice what we have. We have two angles, and we want to find one of the sides, and one of the sides are given. Now for angle 62, you see that the opposite, we have an opposite side of 5.700 inches. And for 39, we have an opposite sine of the unknown. And so in this case, we can use the law of sine. So I decided to put our problem on our whiteboard and to solve it on our whiteboard. So this is our triangle, our X unknown. We have 5.7 inches, and we want to figure that unknown, which is right here, that X. So since we have two angles and a side, and those sides are opposite to the angle, we can use the law of sine. So in this case, what I'm going to do is write the side 5.7 divided by which one do you think I'm going to use? I'm going to use the opposite, which would be sine of, and let me write this as sine of 62 degrees. That will equal to, put the side on the top, our X, our unknown, and here's our opposite angle for that one, which would be the sine there we go, the sine of 39 degrees. Now, this is a matter of doing algebra and getting X by itself. So in this case, to solve for this problem, I'm going to just put an arrow up here so you can see how we're going to do this. We're going to move this sine up here. And so what we end up is the sine, X is equal to 5.7 times the sine of 39 degrees divided by the sine of 62 degrees. So our main thing is to get X by itself. Now, what we should do is find the sine of 39 degrees, multiply by 5.7, and then divide that by the sine of 62 degrees. So you may want to find the values of the sine first as a decimal value, and then do it on your calculator. Now, if you've done it correctly, we're going to end up with X being approximately 4.06267. Now, in our case, we want to round off to 3 decimal places. So here's our 3rd decimal place. In order, we have to look at the 4th, since that 6 is greater than 5. I'll say X would equal to 4.063. That 2 will become a 3. And since that's my answer, and this is inches, I will circle that. Now let's keep this same triangle. Notice I put in green the answer we found before for the side, and these are inches. So just keep that in mind. So we have 62 degrees and 39 degrees. So that, make sure you know that's 39 degrees. Now, can we solve anything else on the triangle once we know 2 of the angles? Well, we know that all 3 angles add up in a triangle is 180 degrees. So if I add the 62 and the 39 together, that will give me a value of, in our case, I want to make sure, so we add these together. And excuse me for a second. Trying to get this pen working, and it seems like it ran out of power. There we go. So we add those 2 angles, and then we subtract 180 degrees from 101. That's the addition of those 2 angles. That would give me my 3rd angle, and it looked like it would be 79 degrees. So I'm going to put that in blue. So up here, we know we have 79 degrees. Since I know that particular angle, I will be able to solve this side here using the law of sine. So let's do it. So in this case, this is my X, my unknown side. So I'm going to write it like this. I'm going to say X, my side, is over which angle we're going to use. That's correct. We use the sine of 79 degrees, the opposite angle, is equal to, and in this case, it doesn't matter which angle and which side that we want to use opposite. I'm going to stick with the 5.7. So 5.7 divided by the sine of the 62 angle. since those are opposite. The angle and the side are opposite side from each other. I could have used the 4.0363 divided by, in that case, I would say the sine of 39 degrees. But I decided to use this, and we'll still end up with the same answer. So we solve for x. X would equal to 5.7 times the sine of 79 degrees over the sine of 62 degrees. Again, I suggest that you find the sine of 79 degrees, write that down, and find the sine of 62 degrees. Multiply 5.7 to that answer, and then once you get that answer, divide it by the sine of 62 degrees. Now, you make sure you do it correctly. I believe I get approximation of 6.3372. So let's make sure we get the same answer. Do it right on your calculator. Make sure you put your parentheses right, especially in your division. Now let's round this off to the third decimal place. This is the third decimal place is right here. That means we gotta look at the fourth to see if we change that 7 to an 8 or just leave it as a 7. In this case, since that 2 is less than 5, my answer, I'm gonna write it on top, is 6.337. In our case, we're talking about inches, and then that's what I will circle, and that's my unknown for x. Now let's look at one more problem. Far as the same problem, we already know the answers to. Now, if you notice, this is similar to the triangle that we did earlier with the numbers. You recall seeing these numbers before. We know the answer to this particular triangle, but I want to show you that, let's say I'm giving you two sides and we want to find an angle, and let's say we want to find angle B. Can we do that in this case? So in our case, let's try to use the law of sine and see what happens. So I'm going to use, here we have 5.7, have a side over the sine of 62 degrees. That's going to equal to 6.337 over the sine of angle B. Again, we're looking at those opposite. The angle on the side that's opposite. That's how we set it up proportionally. Now, let's do some cross multiplication, a little algebra. I'm going to move this up here, move this here, show you how we can solve this. So this will be the sine of B, I'm moving over there, times 5.7. It's equal to 6.337 times the sine of 62 degrees. So what I'm going to do here, and remember this is the sine of B, I'll say the sine of B is equal to 6.337 times the sine of 62 degrees. And I would suggest you find what that value is and then multiply by 6.337 divided by 5.7. Okay. Now, once we do our math here, we're going to end up with a value, and then we're going to take the arc sine to find B. So let's do that. So once we do this, this gives us approximation. Make sure you do your parentheses and make sure you have your numerator and your denominator so you get the right answer. This gives us 0.98162. So we have the sine of B is approximately that. Again, we're not solving for the sine of B, we're solving for just B. So to get B by itself, and we've done this in our previous lessons, so feel free to look at some of my previous videos or other videos that I have to show you how to solve trig functions in the trig section. So this gives me approximately, as I do the sine inverse of this number. Again, you can find in our trig how to solve for angles. This will give me approximation that B will be very close in this case of in our case, are 79 degrees. So the sine inverse or the arc sine of 0.98162 is approximately 79 degrees. And therefore, going back to our previous screen, we know this angle will be 79 degrees. Now let's look at an ambiguous case with using the law of sine. It is possible to have two different triangles with the same two sides and the same angle opposite one of the given sides. A situation of this kind is called an ambiguous case. The only condition under which a problem can have two solutions is when you give an angle is obtuse and the other side angle, the given angle, is smaller than the other given side. Since most problems do not involve two solutions, this situation will not be discussed in any more details. So I want to look at a problem. This will be our last problem. And just pay attention, see how we use this ambiguous case to solve our problem. So let's draw this on our whiteboard and then solve this particular problem. We're given two sides in this case and an angle opposite of one of the given sides as shown in the figure below. And we want to determine angle D. So go ahead and draw this and let's see how you can do it first, possibly using the law of sine. And let's see what answer we get and to show you how this ambiguous case come into play with this particular problem. So here we are on our whiteboard, kind of redrawn what we saw earlier. It was a little, could be a little bit neater, but we have it here. So in our case, let's use the law of sine to solve for this problem. And how we're going to do this, we're going to start with our angles. And notice we're looking at angle D, which is in blue. And so I'm going to write this down, 6.870 divided by the sine of the angle, which is D, corresponding opposite. It should equal to the side of 3.5 centimeters over the sine of the angle 27.6 degrees. So that's 27.6 degrees. So in our case, let's actually solve for D or the sine of D first. I'm going to cross and multiply. So this gives me 6.870 times the sine of 27.6 degrees is equal to 3.5 times the sine of D. So the next thing I'm going to do, and this is 3.5, I'm going to divide both sides by 3.5. And this would cancel here. And so as we look on our next screen, we'll go here, we actually have the sine of D is equal to, and let's go back what it look like it's equal to, 6.87 times the sine of our degree, 27.6 divided by 3.5. So what you want to do is make sure you do that first. You knock that out, multiply 6.87 times the sine of that's 27.6 degrees. Figure that out in the numerator, then divide by 3.5. And we'll go from there to get our answer. So this gives us the sine of D. So the sine of D, I should write it like this, is approximately, if we do our math correctly, 0.90938. Now what we're going to do, we're going to do the arc sine on both sides to get D by itself. So D be approximately equal to the sine inverse or the arc sine. Again, we know how to do this looking at our trig videos and supplementary materials that we have on our MathLink website. And this will give me approximately around, I say about 65.42 degrees. Okay. Now the problem is, now don't underline it, don't circle that. The problem is, let's go look back at our triangle. Our triangle has an obtuse angle. D is an obtuse angle, which means it's greater than 90 degrees. So my answer should be greater than 90. Since this is 65.42 degrees, that is not my answer for this particular problem. And so you say, well, Mr. C, how would I solve that? It seems like the law of sine didn't work. It actually did. And since an obtuse angle is greater than 90, what we're going to do have to use a supplementary. Remember, we talked about that in some previous videos in geometry. So go into the geometry section. We have something that's a complementary, supplementary, and supplement angles. And that means we're going to have to subtract 180 minus 65.42. Why I'm using 180? Because it's greater than 90. And so either we have two angles that add up to be 90 degrees, which is complement, or two angles that add up to be 180 degrees, which is a supplementary. So in this case, I'm going to do 180 minus the 65.42. In this case, this will equal to 114.58 if I did my math correctly. And that will be my answer for this particular problem. So I like for you to circle that orange and then go back to that be our angle D, because angle D is bigger than 90. And this is our angle that is bigger than 90. And that's how I got it, by subtracting 180 from what we have in that case. This is a case that is a special case that we have for the law of sine. So looking at those examples, hopefully this helped in understanding the law of sine. And remember, let MathLink bring it together. Again, thank you for watching this video.